All right, so that's a quick reminder that your quadratic equation in standard form is ax squared plus bx plus c is equal to 0. This is something you would have done already, right, from 3.1. It's just a little reminder. Now, when we have a quadratic, we can also use what we call the zero product property, right? And that's usually when your quadratic can be factorized, you can use this property to solve it instead of using completing the square method or the quadratic formula, right? So not all your quadratics can be factorized. Sometimes there are no common factors where you can get it to be factorized. But once it can be factorized, we can resort to this method. Now, all it is saying is that if you have a times b equal to 0, meaning the product of two numbers is 0, what are the possibilities for a and b? If you multiply two numbers and you get 0, what does that mean? One of them, right, must be 0. So a could be 0 or b could be 0. So when you say or, one is sufficient, but if both of them are 0, then it's still going to work, right? So once you have the product equal to 0, it means that a is 0 or b is 0. So don't say and, because you don't need both of them to be 0. If both of them are 0, then that's a bonus. 0 times 0 is 0. But we just need one to be 0. So use or. So a or b should be 0. Right? Now, then we have what we call the square root property as well, where if you have x squared equal to some number c, where c is a number, then if you want to find x, all you have to do is just take the square root. You do the opposite. So x is going to be plus or minus the square root of c. And when we did imaginary numbers, I did explain to you all that when you square root, technically, the result can be plus or minus. You all remember that example I did? Because let me just do a quick demonstration again. If you have, for example, 5 squared, that's equal to 25. If you have negative 5 and you square it, that's also equal to 25, right? So let's say, for example, you're told that x squared is equal to 25. Then what are the possible values of x? X could be positive 5 or negative 5, right? So that's where the idea comes from. Because if you square the negative 5, you also get 25. So if you do the opposite, the reverse, by square rooting 25, then you should get plus or minus 5. So that is where this idea comes from. So always remember that there are going to be two possibilities, the negative or the positive. Is that clear to everybody? Now, if your c value is greater than 0, meaning positive, that's what this is saying. If it is positive, then if you notice, your graph is going to cut your x-axis twice. You have two real roots. And when we talk about discriminant over here, we're going to discuss that in more detail. Now, if your c is equal to 0, then you're just going to have a repeated root, meaning the turning point will only touch your x-axis once. Notice, just right there. Now, if c is a negative value, right? When you square with a negative, what happens? It's going to be an imaginary number, not a real, so it will not cut your x-axis, right? So this means that the roots are imaginary. That's simply what it is saying. I want to talk about it some more. So in this case, we have two distinct roots or two different roots. Notice it cuts the x-axis two different places. So you have two different solutions for x. And this now you have one repeated root, or you can treat it like this: two equal real roots. These are real. And this is also two distinct real roots. So these two possibilities will make them real. But over here, if it doesn't cut the x-axis, then you only have imaginary roots. We'll talk about it some more for discriminant, so don't worry. All right, let's do some examples. So here we're asked to solve for x. 2x squared is equal to 48. Now, because you learn new properties mean you're going to throw away what you already know. Some of them are very basic, like what you would do in solving a regular equation. So in this particular case, we want to solve for x. What do you think is the first thing we need to get rid of? The 2. So you're going to go ahead and divide 2 on both sides. So it's pretty much similar to what you would do in a regular equation. Now, what are we left with? X squared equals 24. Now, what am I going to do now to get x? Very good. You're going to square root both sides. And what did we say happens when we square root both sides? What must happen? It's going to be what? Plus or minus. Very good. So this is going to be plus or minus root of 24. All right, so it's a plus or minus. Don't forget that. So this means that x is equal to, we could have positive 24, root 24, or x is equal to what? Negative root 24. So that's what the plus or minus stand for. Anybody know how to simplify this? What's the root of 24? Not as a decimal, as a simplified radical. 24 is the same thing as the square root of 4 times 6. Very good. So 24 is the same thing as 4 times 6. You can get a square number from that. What's the root of 4? 2. So this is the same thing as 2 root 6. And over here, it will be the same thing as negative 2 root 6. So that's how you can simplify your radical if you're asked to. If you can extract a square number from it, you can just do that. All right, next example. Now, in this particular case, what do you think is the first thing we need to do to get rid of the square term? Square root, very good. So go ahead and square root both sides. And always remember that when you square root, remember that this right here, it should be the plus or minus, right? I don't have any space to put it, so I'm just going to put it out here. Just remember that it's plus or minus. Let me put it before it so it doesn't cause any confusion. Right, so just remember it is plus or minus. Don't forget. All right, so let's do some work. So we know that square will cancel square root. So we have negative 2x plus 5. And that's equal to what? That's going to be plus or minus. What's the square root of negative 8? You did this in 3.1. What is it? No, not quite. But you're missing something. I, right. So remember that this is the same thing as I times root 8. Don't forget. Because there's a negative inside of the square roots. Isn't that so, everybody? All right. So now we are I'm going to simplify this now. So we are solving for x. So I'm going to bring over this 5. So we have negative 2x is going to be plus or minus. I won't simplify the root as yet, but you can if you want. So this is going to be I root 8. And then we have a minus 5. Now, what will be the next step? We want x, so what do I need to divide by now? Divide both sides by -2. And if this is a test and you leave your answer like this, saying x equal to this right here, I would still give you your full credit. Right, but you can simplify it if you want. So I'm going to show you now how we can simplify this. But as I said, if it was an open-ended test where I just say solve and you give this as the answer, you're perfectly fine. That's all the algebra, you have to follow all your steps. There's nothing to really penalize you for. But I'm just going to show you that we can also simplify this just for knowledge purposes. All right, so what we have again, we have plus or minus I root 8 minus 5 over -2. So let's start with the positive. So we have I root 8 minus 5, and we're dividing that by -2, or the other one was negative I root 8 minus 5, and we're dividing that by -2. Now let's split this and see what we would have. So root 8 is the same thing as what? 4 times 2. What's the root of 4? 2. So this is the same thing as 2i, can take out the 2 if you want. And then we're going to have a root 2. Divided by -2. And then we're going to have minus 5 over -2. We just split the fraction. I want to have a fraction if you're adding or subtracting, and the denominator is the same, you can always combine or split them. What does this leave us with? The 2's would cancel. So that's just negative I root 2. And then you're dividing two negatives, so it becomes positive 5 over 2. So that's how you could simplify. But as I said, if it's an open-ended test, you don't have to do all this work. You could leave your answer the way I showed you. I just wanted to show you that we can simplify these. Does that make sense? Yeah. You want me to simplify the other one, or just leave? Or you think you guys are good? Yes. Simplify? Okay, that's good. So over here, we have the same thing. We're going to have negative. Do the same thing again here. So that's going to be, we can take out a 2, because root of 4 is 2. Then we have another root 2. And this is because root 8 is the same thing as root 4 times 2. So root 4, that's where this 2 comes from. All right? And then we are going to have that over -2. And then minus 5 over -2 is just going to be positive 5 over 2. They have two negatives. Now, these are going to cancel. The negative will also cancel. And so that's just I root 2 plus 5 over 2. If you were to simplify, that's what you would have. Do we have any questions?
So they're the same, plus or minus. If you just put plus or minus and simplify it, would that work?
That would also work. Okay. You didn't have to split it as the positive one side, the negative one side. You could just continue working it as plus or minus, but I just split it so persons can understand what I mean when I say plus or minus. It means one is with the positive, one is with the negative, right? But that would still work. All right, let's continue. Next example. What do you guys think is the first step for this one? Austin, what do you think?
Square root or
No square root. Jackson, what do you think? No clue? Trey, what do you think? Come on, guys. Travis, what do you think? Set what equal to 0?
well, isn't x just 0?
No, x wouldn't be 0.
No.
I mean, it could, but that's only one possibility. There's another possibility. Go ahead, CJ.
We subtract 3x.
If you subtract 3x, that's not helping because you're going to have x on one side, x on another side. So that's going to make it harder.
So yeah, take the x out of it. So like
All right, so Yaya is saying that x is common, so we can factor out an x. Very good. We can factor out an x to get a product, right? So if I take out x, what do I have remaining in parentheses? We're going to have 5x plus 3 and set that equal to 0. Now, what property does this remind you of? When you multiply the a and the b, what do we say we do again? If you multiply two quantities and you get 0, what does that mean? Right, it means that x could be 0 or b to be 0. Right, 5x plus 3 could be 0. Yeah. It's a product. So a times b equals 0. So a can be 0 or the b can be 0. So the same thing we're doing here. Get a product and do the zero product property. Now, so this is already one of your answers, which is what Travis said earlier. So you would have gotten a half mark for that, Travis, which is very good. But this was the other possibility, right? Now, let's solve for x. This is just a linear equation. So we're going to have 5x equal to what? -3. What do I do? Divide both sides by 5. And so we see that x can be 0 or x can be -3 over 5. So those are the two possibilities. Moving on. Wilson, you're following? Yes, sir. Okay. Now here we ask to write this in vertex form and then use a square root property to solve. So this is what you have been doing in 3.2. And I trust that you watched your recording, so you can now do this. Now, what I'm going to do is to get rid of the denominator to make life easier for us. And to do that, we can actually multiply the equation by 6. It's an equation, so if you multiply each term by 6, that will cancel the denominator. So that would just give us x squared. 1 6 times 6 is 1, that's going to cancel. Plus, we're going to have x and set that equal to what? 6 times 5? 30. Now we're going to have x squared plus x, put it in the standard form first, minus 30 equal to 0. Now you want to get it in the vertex form according to the question. That's not the only way to solve it, but the question is asking us to use a specific method. So we got to follow the instruction. Now, anybody remembers what the vertex form looks like? A squared plus b plus c. All right, so you want it in A. No, that's a standard form. This here is a standard form. A bracket. It's A bracket. X minus A all squared plus k. Very good. So this is what they mean by the vertex form. So that's the form you want to put it in. And then we're going to use the square root property to solve it. So that means we need to find our h value, we need to find our k value, and then get it in the vertex form. So let's go ahead and find h. What's the formula for h? B over 2a. Negative b over 2a. And so that's going to be what? What's your b value? X. Not x, 1 is the coefficient. So that's negative 1 over 2 times, what's your a? X. So it's x coefficient, yeah, 1. So your h is just -1/2. Yes, so to find K now, you're going to plug, yes, you're gonna plug -1/2 or -0.5, if that's easier for you to punch in the calculator. 1/2 and 0.5, they're the same thing. So plug that in this function and tell me what you get, this function right here. You're gonna have 1/2 squared, -1/2 squared plus -1/2 minus 30, and tell me what you get for that. What did I get?
829.25.
All right, so when I plug in -1/2, you're going to get 121/4. Or as a decimal, it would be 30.25, 30.25.
How'd you get 121?
Because I work mine as a fraction. I just did mine mentally, so it's 1/2 squared, -1/2 squared. So if you square -1/2, that's gonna be 1/4. Then you're gonna be subtracting -1/2 and then minus 30. I did mine as a fraction, right? But if you do it as a decimal, it doesn't hurt, you get the same result. Or you can plug the fraction in your calculator using the alpha y equal to. All right, so now we can write this in vertex form now that we know the h and the k, right? So that's just going to be x. The fact that h is a negative, what happens here? Minus minus gives us a what? Positive, so that's gonna be x plus 1/2. What's our k? Was your k, I think this should be a negative value. I'm pretty sure it was a negative. Right, so this was -121/4. So that's going to be now all squared minus 121/4, or minus 30.25 if you're using decimal. All right, so that's how you have it in vertex form, and set this equal to 0 because it's an equation. Right, so that's your answer in vertex form. Now we want to solve it using the square root property. So if we need to do that, we need to first get rid of this -121/4 on the other side of the equation. So here you're going to have x plus 1/2 all squared. And if you bring this over, it becomes a what? Positive. So that's equal to 121/4. Now, if I'm using the square root property, what the first thing I need to do? To cancel the square term here. Square root both sides. Good. So go ahead and square root both sides, everybody. So you're going to have x plus 1/2 is going to equal the plus or minus the square root of 121/4. Yep. So it works out nicely. So x plus 1/2 is just going to be plus or minus root of 121 is 11, root of 4, because all of this is inside the square root, by the way. All right. Root of 4 is 2. So now we can solve. So we see that x is going to be, let's start with the positive. So x is going to be 11 over 2. Bring this over, so that's minus 1 over 2. Or x is going to be minus 11 over 2 minus 1 over 2. What's 11 halves minus 1 half? 10 halves, which is 10 over 2 is 5, good. Or negative 11 minus 1 is what? Negative 12 divided by 2. That's just positive or negative 6? Negative 6, right? So those are your two solutions, 5 or negative 6. So usually a problem like this, it really takes a lot more than the regular problems because you have to first put it in vertex form and then you have to solve it. Because that's what the instruction asks you to do. Now, this is not the only way it can be done. We could solve it directly, but you need to know all of these methods. Now we're going to move on to discriminant. Now, when you find the discriminant, you're basically finding the number and nature of roots that your quadratic will have. All right, that's what the discriminant tells you. Now, to find your discriminant, you use the formula b squared minus 4ac. Now, do you know where the b, the a, and the c will come from? It's coming from this format here where you have ax squared plus bx plus c. So the a is a coefficient of x squared, the b the coefficient of x, and then c is going to be your constant term. Now, whenever your discriminant is less than 0, so when you find b squared minus 4ac, whenever this is less than 0, what do you think is going to happen? Very good, right. So this is the situation that you're going to have, right? If your discriminant is negative, you're going to have what we call two imaginary roots. Right? So roots are going to be imaginary or complex. And this would be the situation that we described earlier. It's not going to cut the x-axis because there are no real solutions. We can't take the square root of a negative. And this discriminant formula, it's coming from your quadratic formula, the square root part, what is inside the square root of your quadratic formula. All right, so the solutions are not real, that's what it is saying. Two imaginary roots or solutions. The root of what we call the solutions. Now, when your discriminant is equal to 0, what did we say happened? Like in this case, we have what? We have two equal real roots. So write that down. So you're going to have two equal real roots. Or some books will say, so let me tell you from now, I think that's what your textbook says. It may say one repeated solution or roots. And let me give you an idea what this is talking about. So let's say, for example, you have something like this, x plus 3 times x plus 3. This is a perfect square, right? Equal to 0. It means that if you solve these using the zero product property, what happens? It means that this one, x plus 3 is equal to 0, or x plus 3 equal to 0. Isn't that so? And that's your product. So you're going to see that x is going to equal to negative 3 twice. That's what it means. Because look at this, x plus 3 equals 0 or x plus 3 equals 0. So it happens twice. So that is why some books may say it's a repeated solution. It's one solution that's repeated. Or some books may say they are two identical or two equal real roots. So it doesn't matter how you put it, it means the same thing. And then finally, we have b squared. Whenever our discriminant is positive, what did we say happen? For example, in this case, what happens here? Two distinct real roots. So write that down. Two distinct real roots. So based on the value of your discriminant, you can tell the type of roots that you're going to have. So that's the purpose of it. Now, when you have a square, this is when your discriminant b squared minus 4ac is equal to 0. For example, in this case. And then when you have a non-square, you can have either two imaginary roots or two distinct equal roots. So this means that b squared minus 4ac must not be equal to 0. So once the discriminant is not 0, you're going to have a non-square quadratic term. Let's do an example. So use the discriminant to determine the number and type of solutions. Now, when I get these problems, pay attention, everybody. You have to make sure that you write it first in the standard form. So you can get what your A, your B, and your C value, what those values are. So in this case, we're going to have 8x squared. If you bring over the 14x, it becomes a minus 14x. Bring over the minus 3, it becomes a positive 3. And then you set that equal to 0. So always write in standard form first. Right? So you always put it in standard form first. Always. Now, this is in standard form. Can you tell what your A value is? 8. What is your B value? 14? Negative 14. And what's your C value? 3. Now, what's the discriminant formula again? It's b squared minus 4ac. So that's all you're going to do. Now, plug these values into your formula, and whatever the result is, that will tell you what the nature of the roots will be. And when I talk about roots, we're talking about the solutions, your x-intercepts, the x values, right? Now, let's do that. So b is negative 14, right? If I square negative 14, then we're going to have minus 4 times what is a? 8 times c, which is 3. Work that out and show me what you get. What's negative 14 all squared? What's that? 196, okay. And then what's minus 4 times 8 times 3? Okay. So that gives us what, 196 minus 96? 100. Is that positive, negative, or 0? So what does that tell us? What do we have? 2 distinct, not just say distinct.
2 real distinct.
Very good. There are 2 distinct real roots. You can't leave out the word real. Right? Our roots can also be imaginary, right? So you have to let me know that they are real. Don't forget it. 2 distinct real roots. Now, when you do your homework, you'll come across some others where just remember that whatever the discriminant value is, that will tell you the nature of the roots. So if you had gotten 0, you know that you'd have 2 identical or 2 equal real roots. If you had gotten a negative value, you would have two imaginary roots. Does that make sense? All right, let's do another example here. You want to find the values of A and B and C for which the quadratic equation has the given numbers as solutions. Any idea how we can do this? So in this case, they are giving you the solutions for the quadratic. How do you find the equation? Think about the zero product property. So these are the solutions, right? So you know that when you multiply two things, you get zero. What do I put in those two brackets?
X minus.
No, it can't be an x minus 3 for it to produce x plus 3. Very good. What goes in the other one? X minus 2. Because look, remember that you're going to set each of those to 0 and solve. So when you bring it over, it becomes a negative. Right, so in the bracket, the sign must always change so that when you solve it, you get the desired root that you want. Does that make sense, everybody? Right. Now, look at this now. They want you to have it in standard form, so it means we need to FOIL so we can get it in standard form. So we're going to multiply like this. We're going to FOIL it. And then that will give us what the A, B, and the C are once it is in standard form. X times X, X squared, X times minus 2, 3 times X, 3X, and 3 times negative 2, negative 6, and that's equal to 0. This can be simplified as X squared plus X. You owe 2 things, you pay back 3, you have a surplus of 1. And then we have minus 6 equal to 0. So what is our A? 1. What is our B? 1 as well. What is your C? Negative 6. So that's how you would do a problem like that. Now, sketch the graph of this function that satisfies the given condition. So you're told that A is negative. So if A is negative, what does that tell you about the shape of your graph? When the x squared term is negative, what does that tell you? How does your graph shape? What is it? Come on, guys, I did this in chapter 2 and we reviewed it in chapter 3, the first part. Right, it's going to flip over. So we know that if A is negative, always remember that you have what we call a frown, don't forget it. So your graph will flip over. It's reflected over the X. Don't forget it. Now look at what is happening for this part. Now, what is this part telling us now? Your discriminant is positive. So how many times will it cut the x-axis when the discriminant is positive? Twice, 2 different places, right? So remember that you're going to have 2 distinct, meaning different, real roots. So let's sketch a graph that satisfies those. So all we want here is a graph that is flipped over the X and it cuts your X-axis twice. So any graph at all, you can basically draw it anyhow you want. That works. So any graph that flips over the X and it cuts it twice, the X-axis twice, would satisfy these 2 conditions. So different people can have different answers. Right? It's any graph that satisfies those 2. All right? Because your discriminant would tell you that. Now, let's do another example. Let me get some space. What if you're told that, so this is another example, your discriminant is negative, sorry, your A is negative, and your b squared minus 4ac is negative, less than 0. What would this graph look like? So a is negative, so that means that it's gonna flip, right? Remember your frown? So we know that already it's gonna flip. And what about this part here? Your discriminant is negative. What does this tell you? What happens when the discriminant is negative? It doesn't cut the x. You all remember that? Right. So there are no real because they're both imaginary. So 2 imaginary. So it means that it's not going to cut the x. So it would have to be somewhere under the x-axis. Very good. So any graph that is on your x-axis that concave downward would work. It could be on the left side, the right side, the middle. It doesn't matter as long as it's under the x. It must not cut the x-axis. Because we don't have any real solution. They're both imaginary. Now, finally, what if we have an example like this? You are told that a is greater than 0, meaning positive. And then you're told that b squared minus 4ac is also equal to 0. What does this look like? It doesn't have to be the origin, but it can be at the origin, right? So we know that in this case, you have a smiley face, isn't that so? So your graph must concave up. Yeah, happy people, they're positive. All right, so we know it's gonna concave up, but what happens here when the discriminant is 0? You have what we call a repeated solution. So it's only gonna cut the x-axis at one point, and that's where the turning point is going to be. So CJ, you were saying it's gonna be at the origin. It can be. So you could have something that looks like this. And then it goes up. Right, something like that could work. As it just touches at one point. Or you could have something like this. Right here as well. So any of those would work. All right, so you may want to take down these examples. So this part of the course is really not so bad. It's manageable. It's more like just, knowledge. So either of these could work. All right, so now we're going to move on to how we solve inequalities. All right, so when you get this to solve, notice here that this is an inequality. So please write down the steps so you solve this. So first, solve the equation. So first you are going to solve the equation. Right here. So solve the equation. EQN, that's my shortening for equation. And then sketch the graph. Oh no, this is enough. So graph the equation. Sorry. So solve the equation. And then we are going to sketch the graph. And read off solution. That's my shortening for solution, guys. As you can see, I have difficulty writing. It's not so easy like what you have.
What is that, sir?
So solve the equation, and then you're going to sketch the graph and read off the solution. So SOL with a letter N at the top is a shortening in math for solution. So add that to your math dictionary. Read off the solution, yes, read off. Meaning you're going to use the graph to tell the solution, right? So the first thing we're going to do is to solve the equation first. Now, in this case, it didn't specify how I should solve my equation, so I'm going to use my zero product property by factorizing. Now, we have our AC 1 times 8 is 8. From the beginning of college algebra, I've been telling you all to review factoring quadratics. I hope you did. That's what I'm going to do to solve this one. Now, are there any factors of 8 that I can add to get 6, which is my B value, and also multiply to get back 8?
2 and 4.
2 and 4, good. So this is just going to be x plus 2 times x plus 4 equal to 0. I'm solving the equation first. I'm converting this to an equation. Now use your zero product property. What are the values now? You know that x plus 2 equal to 0, or what's the other possibility? X plus 4 equal to 0. So x would be what? X is negative 2, or x is negative 4. Now let's sketch the graph. Guys are good? Now let's sketch the graph. And it's a very rough sketch, by the way. Now you know where it must cut your x-axis. Look at this, everybody. It's at negative 2 and negative 4. So let's say we have negative 2 here. And here we have negative 4. It's a very rough sketch. It doesn't matter. You don't have to be by scale. We're just going to use it to read off the inequality solution. Now, look at the shape of your graph now. What's the sign, your square term here, what's the sign of your A? Is it positive or negative? So what does it shape like? Does it concave up or down? Is it flipped over or not?
It's not.
It's not. So you know that your graph is looking somewhat like this. You're going to cut it at negative 4 and at negative 2. Let me use a different color to draw my graph. Right? There's a graph that cuts it at negative 4 and negative 2. Now, use it to read off your solution. Look at this now. You want the solution where the graph is negative, right? Because the inequality says less than 0. Where is this graph negative? When it's below the x-axis. Because y is negative below the x-axis. So it's this is the region that you want. So you want x to be what? Very good. Range from negative 4 to negative 2. And we use parentheses because it's a less than problem. So we're not including the endpoints. So once you sketch the graph, look where the graph is negative. Meaning, where is it below the x-axis? It's in this little region here. Now let's look at part B now. In part B, we want where the graph is above. It's the same problem, by the way. So no need to factor it again and do all that stuff. It's the same thing. You want to look now, where is the graph greater than or equal to 0? Meaning at the x-axis or above it. And in this case, we're going to be using square brackets because what we have here, greater than or equal to. Now, where is this graph positive? Where is it above the x-axis? Over this region here, meaning to the left, and also over here. It's always above the x-axis, right? So it's just going to be from negative infinity to where? -4, but use a square bracket at -4. Why? Because it says greater than or equal to. And then union to join the other part, -2 to infinity. And that's your solution. So if you have the same problem, no need to go and factor it again and do all of that, because you would have done that already for part A. Unless it's a different equation, of course, then you would. All right, so that's what you would do for those problems. Here we have another example. Even though this say use completing the square method, you don't have to. You can just use any method you want. So write in vertex form and then use square root property to solve. Now this one is very similar. Let me show you, because I'm going to have you try this on your own when you get home. You can have a tutor check your answer, or you can have me check it in our next class. All right, so it's similar to this problem here that we did. I'm looking for it right here. This one right here, that's what you're doing. So look back at this example and use it to solve the other one. All right, so you know you're going to find your h and your k, because this is the method they want you to put it in. A, then you're going to have x minus h all squared, and then plus your k, and set that equal to 0. That's the method they want you to put it in. You already know how to find your h, it's -b over 2a. And you know that your k is equal to what? F of whatever h is. And then put it in this form here. And then use the square property to solve, where you square root both sides and you work it from there. Now, notice what you have here. You can rearrange this. This is not in the standard format. You can rearrange this to be -3x squared plus 16x minus 5 equal to 0. That's saying the same thing. So you can know that -3 is your A, 16 is your B, and -5 is your C. All right, I'm going to tell you what your answer should be. Your final answer, it should be x equal to 5 or x equal to 1/3. Now, if when you solve it, you do not get it, please let me know, right? Or when you go to tutoring, you can have one of them walk you through it. But it's very, very similar to what you would have done in the previous example. So just follow the steps and try to get it. Now we are moving on to 3.4, and this is our application section. And I can almost guarantee you that this problem here, 3.4, this very first application problem, it is always on your test. So make a note of that. And it is always on your final exam, a problem similar to this. So I'm telling you guys my secret. It's always on it. All right, so let's look at what is happening here. So a piece of sheet metal is 2.5 times as long as it is wide. So it is 2.5 times as long as it is wide. It is to be made into a box with an open top by cutting 3-inch squares from each corner and folding up the sides. Let X represent the width of the original piece of metal. So this is the original piece of metal. And what they're doing, they're cutting 3 centimeter squares. Sorry, 3 inch, the unit is inch. They're cutting 3-inch squares from each corner to form a box, open top box. Can you picture what that looks like? So when you guys go home, you can try something like this. So all you do, cutting squares from the corners and then just fold it up to form a box. Tyler, can you show what that looks like?
The box.
Yeah. So it's like you have a square or a rectangle. On my camera, so my online students can this works. So it's like you have a rectangle. Can you all see that? And so if you get like a scissors, I don't really have one here with me now, but what they're going to do is remove from each corner. And my box is going to be very, very ugly because I'm just tearing things. All right, so they remove the squares from each corner and then they just fold it to form a box. All right, so your box would look somewhat like this. So it's a box with the top open. Can you all see that? So that's what they're doing, right? So let's see if we can make some sense out of the problem now. Now we are told that the original side of the square, the width is x. So what is going to be the length? How much time is the length more than the width? They told us that. 2.5. So your length is going to be 2.5 times x. So you would have answered your first question. The length of the sheet in terms of x would just be 2.5x. Very, very easy. How many times is the length more than the width? That's what they're asking you. Now, are there any restriction on x? Are there any restriction on x? Is there anything x cannot be? Well, look at it. Look at what they're removing from x. So you have this entire distance here is x, right? How much are they removing in total? 6. Very good, because they're moving 3 here and 3 here. So what does that tell you about x? It has to be bigger than 6, right? That's the restriction. X has to be bigger than the total that you are removing, right? So x has to, let me write this better. X has to be bigger than 6. Because remember that length cannot be negative. And in this case, the length will not be 0 because you're taking something from it. So you have to have something there, right? So x has to be bigger than 6. Does that make sense to everybody? That x has to be bigger than 6? All right. Now we want a function for the volume of the box in terms of x. So you all remember volume? It is the length times the width times the height. That's your volume. So let's see if we can establish those. What is the length of the box now? Not the metal, but the box. What will be the length? 2.5x minus 6, right? Because they remove 6 from it, 3 from each corner. Sorry. What would be the width? Right here, the width. X minus 6, very good. So it wouldn't be x minus 3 because you remove 3 from each corner, so it's 6 in total. What's your height? Very good. Because that's the length of the side that you would have been removing, so 3. So just multiply the 3, so your volume function is just going to be 3 times x minus 6 times 2.5x minus 6. And you don't have to FOIL, you can leave it as it is. I'm perfectly fine with it like that. Now, for what values of x, talking about the original width now, for which the volume of the box is between 600 and 800. So in this, you would use your calculator. So quickly pull out your TI-84. And you're going to look for the value of x for which the volume of the box is between 600 and 800. All right, so go to y equal and put your volume function. What was it again? It was x times x minus 6 times 2.5x minus 6. Oh, it should be 3, yes. That would have put us in some serious hot water. All right, and then they gave you some volume, right? You want it between 600, so let y2 be 600 and let y3 be 800. All right, so we would have those, now graph it. And chances are we're gonna have to change our window values because those values are really big. So let's go to window and I'm gonna increase my X max to probably about 30. And I'm going to increase my Y max to, if you're going between 600 and 800, we can probably use 900 or 1,000. Let's go back to graph. That's good enough. And what intersections do you guys think I'm going to need now to know where X fall in between? Would I need over here where X is negative? We don't need that because we already established that X has to be bigger than 6. So these are the two intersections you're going to calculate and find out the values of X, right? Where the volume is between 600 and 800. Is that clear, Jackson? Okay. All right, so we calculate it now. So second, calculate and go down to intersect, that's number 5. Let me start with the least one right here. Enter 3 times. Oh, sorry, we need a second curve. So make sure when you're gonna click the second curve, you need it on the blue one. Does that make sense, everybody? Because the first, you want to find the intersection with the red and the blue. So I'm gonna click that and then click enter another time. The intersection is 13.32. So we know that X must be greater than 13.32, but less than, let's find the upper boundary. So you're gonna do the same thing. I'm gonna second quit and go back to my graph and calculate my intersection now for the top one. So do the same thing. Second, calculate, number 5. And just use your arrows. So for my first curve, I'm gonna pick the black one. For my second curve, I need it to be on the blue. And then click enter again. Enter 3 times and you'll get 14.68. Right. So we just graph it and then use your calculator to determine the intersection. And as I told you all before, one of this type of problems is always on your chapter 3 test and also on your final exam. So you must get it. You do not, let's see here. Oh yeah, it's there. All right, so let's continue with this example here. take a minute to read it and let's run through it. So a kite is flying on 50 feet of string, as you can see here. So this probably, let's say you're here and you're flying a kite on a 50 feet string. You're told that how high is it above the ground if the height is 10 feet more than the horizontal distance. So I'm gonna call the height X. And if the height is 10 feet more, then the horizontal distance would have to be X minus 10 or 10 less than whatever the height is. Another way you could draw this diagram as well is it could be done like this. It doesn't really matter. Right, so let's say you had let the horizontal distance be X, this is 50. Then the height in that case would be X plus 10. Does that make sense? Because the height is 10 more. So this is another way you could do it. But you'd have to remember when you solve for X, that's not the height. To get the height, you will need to add the 10 to it, right? So either way you could use to solve it. Now, what theorem can I use to find X? Pythagorean, very good. Which is something we did not too long ago. Remember that we say that A squared plus B squared must be equal to C squared. So here we're going to have X minus 10 all squared plus X squared, and that's going to be 50 squared. Now let's expand here. Who do we get? You can FOIL it if I don't remember the shortcut method, always remember you can FOIL it. So first term squared would be what? X squared. 2 times the product. Minus 20x. Negative 10 times x is negative 10x. Times 2, negative 20x. Last term squared. 100. Write back your x squared. And what's 50 squared? 2500.
Is negative 10 squared 20x or negative 20x?
If what?
Could you square negative 10?
To get 100. That's the last term squared. Yes. Quickly, let's solve this. What's x squared plus x squared? 2x squared. Then we have minus 20x. What's 100 minus 2500? Minus 2400. And set that equal to 0. All right, notice that 2 is common to all of these, so we can divide through it by 2 to get rid of this denominator here. Sorry, get rid of this coefficient. So if I divide by 2, that's going to give me x squared minus 10x minus 1200 equal to 0. Now, can this be factorized? Yes, it can. Are there any factors of negative 1200 that you can add to get negative 10 and multiply to get back negative 1200?
Negative 12. Yeah, negative 12 times 10.
If I add those, you wouldn't get negative 10. Yeah.
120, 40 and 30.
Very good. Right. So a quick trick. Think of the 1200 as 12. Factors of 12, 4 and 3. So if it's 1200, thinking about 40 and 30. But when you add them, you want to get negative 40, right? Negative 10. So I'm going to use negative 40 and positive 30. So that's going to be x minus 40, x plus 30. That would satisfy the conditions. You see, factoring is so much easier than completing the square once it can be factorized. Now, this would mean that x is equal to, let's solve this, x would be 40 when you bring it over or x equal to negative 30. Can x be negative? It's the length that we're talking about. Can it be negative? So you're going to reject this possibility. It cannot be correct. And so this is your result here, that x is going to be 40 feet. This is your solution. Now, this is just a hint for number 29 in your homework, right? I can set it up and use Pythagorean theorem, right? So you can use that hint to do your homework problems. Next class, we'll pick up with 3.4 and then move on to 3.5. I'll see you all next week, Monday.